In this video, we're going to be looking at this book on differential equations, and I'm going to go through every single section in this book and just show you some examples and talk about some of the ideas that are covered in this book. Hopefully after watching this video, you'll actually know some stuff that you didn't know before, and you probably won't understand everything, but that's okay, you don't have to. As long as you get something out of it, that's worth it. This book is great for learning differential equations because it has so many examples and it goes along really well with what's taught in a college level course. Also, this is the second edition. I'm pretty sure there's a newer edition out now. I will leave a link in the description once I find it, so you can check out the reviews, and also if you decide to buy it, you can use that link. I think this is a great book. I've had it for years, I've used it. Let's go ahead and jump into it, and I'm gonna skip the contents, and I'm just gonna jump into the actual math. This is the very first chapter. It's on basic concepts, and I always thought that this is a really cool section in every differential equations book because this is where it teaches you like all of the basic things that you need for differential equations. For example, what in the world is a differential equation? It's an equation involving an unknown function and its derivatives, and then here it just gives you some examples. So dy dx is equal to 5x plus 3. That means that the derivative of y with respect to x, so the rate of change of y with respect to x, is equal to a line, which is 5x plus 3. That's an example of a differential equation. And then here you have some more complicated ones. The 2 here means it's the second derivative, then 3 is third derivative. And then here you have the second derivative cubed, etc. So you see, it gets more complicated. Now these are all ordinary derivatives, so this is called an ordinary differential equation. So ordinary, 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 ordinary. That is what's called a partial derivative. That's called a partial differential equation. And you can see here, they explain everything in the book, which is really, really cool. I think it's great to get a book that you can just start reading and start understanding right away. Here it keeps going and gives you many more specifics. It talks about what a particular solution is, what a general solution is, and it gives you nice examples. And one of the things about these types of sections in these books is that when you get to the problems, they're really, really fun. I think they're fun, and it's because a lot of the problems are very unique. There are questions about the actual definitions, questions about the actual concepts. So they really get you to think, and a lot of times they're really easy. If you just know the definition and you think carefully, you can work through them. And one of the great things about this book is that it solves a lot of problems for you, right? These all have solutions, which is really, really awesome. These are the supplementary problems for the first chapter, and you see there's tons of exercises that you can do for practice. So there are no lack of practice problems in this book. I should mention that this book does have answers to these supplementary problems, which makes it extremely useful as a source of self-study. Chapter 2 is really interesting because this is something that is typically not found in other differential equations books. So this is cool because it shows you the different types of differential equations and it talks about them. So it talks about linear equations, it talks about Bernoulli equations, it talks about homogeneous equations and separable equations. And it's just focusing on the different types of equations, not necessarily solving them. Chapter 3 is a really exciting section for someone who knows some calculus and is ready to jump into differential equations, because here you can actually start solving differential equations because we're focusing on what's called separable differential equations. And I love the way the author treats it here because look, it's just basically saying you can separate all of the x's together with a dx and separate all the y's together with a dy, and then you can just integrate. Now typically what I do is I put all the x's on one side and all the y's on one side and then integrate both sides. But yeah, really nice section and it's got tons of problems. Chapter 4 is on exact first order differential equations. So here you see they talk about what it means for a differential equation to be exact, and then they give you the method of solution for these types of equations. Chapter 5 is where you learn your first real specific differential equations technique, which is really kind of cool. Basically, you're focusing on solving linear first order differential equations. And to do that, you have to compute this mysterious quantity known as an integrating factor. And here they define it. And this is a really interesting process, and the justification for this process is also very, very interesting. But yeah, they go through it here and they give you lots of examples. Chapter 6 is on applications of first order differential equations, and there's tons. And if you're taking a course in college, you may only cover some of these. So here they talk about growth and decay problems, temperature problems, these rely on Newton's law of cooling, and falling body problems. They also talk about dilution problems, electrical circuits, and orthogonal trajectories. This is a really fun section as a math person. I love theory. This is the section on the theory of solutions of linear differential equations. And this is really cool because you get to learn some linear algebra. So if you don't know any linear algebra, this will basically teach you some linear algebra. Look down here, it's already talking about linearly independent solutions. If you don't know what that is, that's okay. This book shows you. It's really, really cool. A lot of people take differential equations without knowing linear algebra, and they end up learning linear algebra while taking the course, which makes it such a cool course because you learn so much math from different areas of math. Chapter 8 is on second order linear homogeneous differential equations with constant coefficients. It sounds super hard, but it's actually extremely easy. This is one of the easiest type of differential equations that you can learn to solve. And here it goes through all of the cases, case 1, case 2, and case 3. And then it gives you tons of solved problems as well as supplementary exercises that have answers. Chapter 9 is basically an extension of Chapter 8. Now you're looking at higher degree equations like degree 3, degree 4, degree 5. And the method is very, very similar. So it's a really easy transition to go from Chapter 8 to Chapter 9. Chapter 10 is where it gets really crazy. The problems start becoming really long. This is the method of undetermined coefficients. And the problems get pretty nuts. It's not uncommon for people to spend 20 minutes, 30 minutes on a problem when they're first learning. So it takes some extra effort once you make it this far into the Schaums. Just to give you an example, here's a specific problem. So we have the second derivative minus 6 times the first derivative plus 25y is equal to this. And they go through and they solve the problem. And look at all of the work over here. I mean, there's a lot of math going on here, right? So you can see it gets very, very messy in this section on undetermined coefficients. Chapter 11 is on variation of parameters. This is a very specialized technique for solving non-homogeneous linear differential equations. And it's a really cool technique, and I think the book does a pretty decent job at explaining it. Chapter 12 is an entire chapter focused on initial value problems, which is not something you see in a regular differential equations book. So here's their first example. This is called an initial value problem because you have a differential equation and then you have some initial conditions, and you basically use these conditions to pick out a particular solution from the general solution. So you see here, this is the final answer. This would be the particular solution to the problem. Chapter 13 is on applications of second order linear differential equations. And here they give you various applications of higher order DEs. In particular, the spring problem is the one you would most likely encounter if you were to take a course on DE in college. It also talks about electrical circuit problems, buoyancy problems, and classifying solutions. Chapter 14 is a good example of why I love math books, because you can just start anywhere, right? And this is a good example of a situation where you can just buy this book and you can start reading this section first, because this is really separate from everything else you kind of see in the book. And it is related to differential equations. You basically use these to solve differential equations, but here it treats them as their own creature, you know? So it defines a Laplace transform as this improper integral if the integral converges. Then it goes on to give you some properties of the Laplace transforms. Chapter 15 is on inverse Laplace transforms. This is something that you absolutely need to use in order to solve differential equations. Generally speaking, when you're trying to solve a differential equation using these Laplace transforms, you basically take the Laplace transform of both sides of the DE, you solve for the Laplace transform of the function, and then you find the inverse Laplace of that to get back the original function. That sounded like a lot, but it's really not that bad once you learn how to do it. In any case, this is something that's absolutely essential for solving DEs, and you can see that I've done several of the problems here because I have them scratched out. Chapter 16 is on convolutions and the unit step function. This is a really cool topic and one of my favorite. This is something that you would see in a differential equations course or possibly in a specific engineering course. I know electrical engineers do a lot of stuff with Laplace transforms, and so this is stuff that you would see as an engineering student. Finally, in chapter 17, we are solving differential equations using Laplace transforms, and it goes through the method here, and it does a pretty good job. And these are great. These problems are so good. It is so good to have examples that you can actually work through and solve. So it really, really helps when you're taking differential equations or when you're trying to learn differential equations on your own. Chapter 18 is on solutions of linear systems using Laplace transforms. Now this might be a topic that is not covered in your differential equations course, mainly due to time constraints. And that's one of the nice things about Schaum's is that you have all of these topics in here that might not be covered in the course. So if you want to learn extra stuff, you can. And if it happens to be covered in your course, you have a reference that actually has that topic in it. Chapter 19 is on matrices. That's right, matrices. It talks about matrices and vectors, matrix addition, scalar and matrix multiplication. You see, it has some examples there. And then differentiation and integration of matrices and the characteristic equation. Chapter 20 is an entire chapter devoted to e to the at, where A is a square matrix, and they basically show you how to compute e to the at in this chapter. Chapter 21 is a more specialized topic which may or may not be covered in your course. It's reduction of linear differential equations to a first order system, and it goes through and it gives you the process to do that. Chapter 22 is on solutions of linear differential equations with constant coefficients by matrix methods. That's really, really cool. And again, this is something that you might not see in a regular differential equations course. So you have it here, which is really nice. So you have an alternate way of doing problems. Chapter 23 is something you might not see in a differential equations course. This is on linear differential equations with variable coefficients. So kind of a cool section where you can learn some stuff that you may or may not cover in your actual DE course. Chapter 24 covers regular single points and the method of Frobenius. So here we're basically using infinite series to solve differential equations. And here's the problems can get pretty insane. It's not uncommon for a problem to take you 20 to 30 minutes to solve when you're first learning how to use series to solve differential equations. Chapter 25 is on the gamma and Bessel functions, and here they define the gamma function, gamma of p, for any positive real number p by the following improper integral. And they go through and they show some properties of the gamma function. Then they talk about Bessel functions. It says, let p represent any real number. The Bessel function of the first kind of order p, j sub p of x is, and they give you this infinite series. Really cool. Chapter 26 is in an interesting place because sometimes this is taught at the beginning of the course. This is on graphical methods for solving first order differential equations. So basically you talk about direction fields and also Euler's method. 27 explores some numerical methods for solving first order differential equations. Starts off with some general remarks, then it gives you a modified Euler's method. And then over here it talks about the all-popular Runge-Kutta method, and then some other methods here. So this is something that you may or may not cover in a regular course, but it's really nice to have all of these in one book. 28 is basically more numerical methods, except now you're looking at systems of differential equations. So it talks more about Euler's method and the Runge-Kutta method, and then this other method here. Chapter 29 is on second order boundary value problems. Really cool. And it's interesting that it has an entire chapter on this. Then it talks about eigenvalue problems and Sturm-Liouville problems. The very last chapter is chapter 30, and it's on eigenfunction expansions. It talks about the Fourier sine series and also the Fourier cosine series. Overall, I think this is a really good book on differential equations. Hopefully after watching this video, you have a better idea of what differential equations are and what types of things you would learn if you decided to study differential equations. This is a great book for anyone who wants to do self-study or anyone who wants to supplement their course or supplement their other books. It's one of the many DE books I have, and so I thought I would just make this video and go through it and talk about it, and hopefully you've learned something. I hope this video has been helpful. Good luck and take care.